Bismillahirrahmanirrahim. Assalamualaikum and a very good day I bid to all of you. First of all, let me introduce myself. My name is Nur Ainaa Aisyah binti Azizan with matric card number A18KA0114. So my role for this project is as a project manager for LWX Consultants dan Berhad. So this is a presentation to present about my minor presentation, Earthwork, Water Reticulation and EICP department. So the first one is for Earthwork department. So basically, earthwork is the modifying of earth in order to make it suitable for construction. Earthwork also can be used to reshape or heighten a site. The volume difference between cut and fill should be minimal, since disposal or transportation of soil from one location to one location will take a massive amount of time and cost. Earthwork also used to produce the best possible design that will offer the most sustainable and cost-effective building. Earthwork consists of excavation, grading, temporary shoring, cut and fill, compaction, and also disposal. So the objective for Earthwork department is the determination of purpose level, cut and fill process by using grid method within the site boundary, cross-section of the site plan after cut and fill work, slope stability analysis by using Bishop simplified method of slices. So this is the purpose level. As you can see, on the left side is the first purpose level, and the right side is the second purpose level. They minimize the purpose level, the height of purpose level. So this is cut and fill using grid method. For the first purpose level, the difference between total cut and fill volume is 113,827.83 meter cube with a percentage difference of 38%. For a second purpose level, the difference between cut and fill volume is around 17,708 meter cube with a percentage difference of 7.91%. So as you can see, the percentage difference for the second purpose level is much more lower than the first purpose level, as we want the percentage difference is below 15%. So this is cross-section of site plan. So the above one is the cross-section of y-axis. As you can see, the cut area or the cut volume is much more bigger than the fill volume. For the cross-section for the below one is for the view of x-axis. It consists of cut and fill volume. Total of what I can see is, we can say, equal. So lastly, for slope stability. For slope stability, the most critical place with height difference of 3 meters between the reservoir and the road. So by using the Bishop simplified method, after 3 time trials, it is proven that the slope is safe. So the next one is a presentation for water reticulation department. So basically, water reticulation is a water distribution network that collects and treats water before distributing it to consumers. An adequate and sufficient supply of water is essential for cattle to drink, feed preparation, and for sundry other use. The factor that needed to be considered for implementation of water reticulation system included size and types of pipe, location of pipe, design of flow rate and pressure, location of storage water tank, pumps, and so on. Water reticulation are designed to meet the water demand requirement of consumer premises, which comprise of residential area, industrial area, commercial buildings, and other type of premises at different pressure and water capacity. So the objective of water reticulation department is to determine the most economical and appropriate size of pipes, to determine storage water tank capacity and elevation of water tank. Next one is to determine water demand in the development zone area. Next one is to determine the flow rate in each pipe. And last but not least, to ensure the minimum residual pressure heads at peak and firefighting flow are satisfied. So for the pipe, we use the mild steel pipe with diameter of 150 millimeter and Hazen-Williams coefficient of 130 were used in both peak flow analysis and fire flow analysis. The storage tank capacity is 3,186 meter cube after we calculated. So for the network system, we use the closed loop pipe network by using Hardy cross and head valence because it is useful when the maintenance of pipelines in order to make sure the water can be supplied to the consumers. So for water demand, after we calculated, we get around 288,07440 liter per day. Water demand is calculated according to the Uniform Technical Guidelines Water Reticulation and Plumbing by Suruhanjaya Perkhidmatan Air Negara (SPAN). And for the elevation of water tank is located at the highest elevation, which is 40 meter, while top water level and bottom water level is 50.3 meter and 56.3 meter respectively. So the maximum allowable velocity, the velocity of pipeline must be lower than 2.6 meter per second to prevent erosion issues due to turbulence at high velocity. The maximum allowable flow velocity in the suction pipe of pump system is 0.2 meter per second, which is purposed to reduce the problem of cavitation in the pump. So this is the water tank diagram after the water reticulation design it. This is the water tank diagram. So the fire flow rates, our site project are categorized as Class D risk for residential area. Hence, only one fire hydrant used simultaneously with the design flow of 1,140 liters per minute for the proposed development area. So after we calculate, the fire flow rate is 22.374 liter per second. So as you can see in the diagram shown, it is located at node 33. So the peak flow and fire flow rates is calculated by 3 software. The first one is ePlanet. So from ePlanet, we can conclude that the peak flow and fire flow analysis is adequate. And the next one is using MATLAB, using Hardy cross method. So in theory, the peak flow and fire flow rate should be the same as ePlanet. But the final flow rate generated had a significant difference between the final flow rate value than in ePlanet. So in order to counter that issue, we use Excel, but using the same Hardy cross method, we use the Microsoft Excel. So we can conclude that the peak flow and fire flow analysis is adequate. So the last department will be ESCP department, Erosion and Sediment Control Plan department. So the objective for the ESCP department, the first one is before that, let me briefly introduce you to what is ESCP department. So erosion and sedimentation are a natural processes. It's also a result from earthwork, which require deforestation, cut and fill activities. Erosion is the detachment, entrainment, and transport of soil particles from ongoing development and construction areas. Sedimentation is the transportation and deposition process. This process will give adverse effect on the water quality and build-up of sediment on the land surface. Hence, comprehensive and effective control is required to overcome the impact of erosion and sedimentation. So for the objective, the first one is to design the temporary earth drain. Second one, erosion and sedimentation control. And the third one is sediment basin design. And the last one is wash through. So for temporary earth drain, A temporary earth drain is used to divert runoff. It protects against erosion by directing runoff to an erosion control device like a silt trap or a sediment basin. So as you can see, the design criteria for the temporary earth drain is the first one, rainfall estimation. The second one, estimation of peak discharge. The third one is hydraulic design of a channel using many formula. The diagram below is the hydraulic design. The next one is erosion and sediment control. The criteria used is soil loss estimation and sediment yield estimation to calculate the erosion and sediment control. So the next one is the sediment basin design. So the basin outlet for zone A is 2.55 meter and zone B is 2.45 meter. Okay, the last one is wash through. So a wash through is an area where the heavy trucks and other machineries are cleaned from dirt from exiting the site. It is also to prevent sediment both from body and tires of those machineries from being tracked and transported onto public roads. So I think that's all from me. Have a nice day. Thank you.